Hello, everybody. My name is Abhijit, and welcome to Calc 1. This will be a series of lectures. I'm guessing it'll be somewhere around 25 to 30 in that range. I'll be going over the main topics, all of the main topics in Calc 1, and usually every topic I follow up with some example problems to understand how things work out. Also, I'll also trying to help with the intuition of said concepts. The prerequisites for Calc 1 are going to be beginner algebra, uh, factoring out uh, equations, quadratic equations, solving them, trigonometry, and geometry. Not too advanced, anything, obviously. But yeah, Calc 1 is one of the most fundamental classes in math, and pretty much all of engineering students have to be taking this one along with Calc 2, Calc 3 differential equations, linear algebra, if I'm correct. Although that kind of depends, varies based on their major. And yeah, let's dive right into it. We start off with functions. Now, what are they? What is a function? Function, think of it as a box, as a mysterious box, and you throw in something, and it gives you out gives you something else. Let's say I throw in an apple, it gives you an orange. Uh, I don't know, I don't know if the analogy is the right one, but you get it. You say you put in $10, it's gonna give you $20. Increase the input by 10. Let's say you give $70. Then it's gonna give you 70 plus 10, $80. A function need not just add things, it can subtract them, multiply them, divide them, exponentiate them, take the logarithm, all of which we'll discuss what they are. But yeah, it can perform any mathematical operation. It takes in something and spits out something else. Now, the set of all the inputs is called the domain, which contains everything that you can throw as an input to this function. And everything the function spits out, that entire set is called the range. So domain is a set of all input values you can throw into the function, and range is the set of all output values the function gives when you throw all of the input values. You can refer x as being the input and y as being the output. I'm sorry, not exactly y, f of x. F of x being the output, meaning a function is applied on x. This is read as f at the value x or f of x. You can also see two other words being associated with x and f of x. They are usually called image for f of x and pre-image for x. Now, these are not as common as input and output, but you will definitely see them in textbooks. The usually used letters for functions are f, g, h, and so on. Now, there are limitations to what a function uh, can be. Essentially, what do you call a function and what do you not call a function? Look at this. A function can only have one associated value in the range, meaning every element in the domain can only have one output. You cannot have this. You cannot say, okay, I throw in something and the function is going to give me two different things. That doesn't work. So that's not a function. One input can only have one output. Now, two different inputs can have the same output, like this one, the first one and the second one giving the same output. That can happen, but this cannot happen. Let's look at an example. Y equals f of x equals x squared. Now let's throw different values. When x is 0, y is 0 squared, which is just 0. When x is, let's plot that. And when x is 1, y is going to be 1. When x is 2, y is 2 squared, which is 4. When x is 3, y is 9. When x is minus 2, y is minus 2 squared, which is still 4. And when x is minus 3 squared is 9. So we plot all the points. Also passes through the origin. Now, because this function is continuous, we draw a straight line through all of them, which gives you an approximate plot in this range again. Now, what is a continuous function? We'll discuss later. Now let's move on. Vertical line test. As I said before, a function can take an input and it can only give one output for that corresponding input. It cannot say, if you throw in 7, the function cannot say, okay, the answer is 17 and the answer is 24. No, it cannot give you two outputs. It can only give you one output. When we draw this as a graph, y being f of x, y being f of x, the vertical line test says that if you draw a vertical line perpendicular to the x-axis and parallel to the y-axis anywhere in the graph, it must only cut the function at one point, or at most one. It cannot cut the function at 2, 3, or more than one point. So this cannot be a function. That can be a function. Discrete functions are something where the values of x are not continuous, meaning they are either integers, natural numbers, whole numbers, but not the real line. So even the output is going to be just points. So the plot is just point, point, point. You don't draw a curve. through them. That's where you stop. That's a discrete function. Piecewise functions. Now, a function need not be defined the same way throughout the domain. Again, what is a domain? Let's go back. Domain is the set of all values that x can be, meaning all the values that the input can be. Piecewise functions do this. They look at some part of the domain, and for that, they give you one output, and for the other, they give you another output. So from 0 to 2, it says, okay, I'm going to take in the input and I'm going to square the input. But once you cross 2, it's going to say, okay, now you're greater than 2. I'm just going to output 4 for every single number you throw at me that is greater than or equal to 2. That's 4. It's a constant function, essentially. Now let's look at another example. When x is between 0 and 2 but not equal to 2, again it says, okay, I'm gonna give you x squared, but if x is greater than or equal to 2, it says I'll give you a line. Or let's take a step back. More simply, it's going to say I'm gonna take the input, I'm gonna multiply it by 4 and subtract it by 3, which is a line, essentially. Back to geometry. And that is the function. That is how the graph of this function looks. Absolute value function or modulus function. Now, what is this? Even this is a piecewise function where for all the positive values of x, for all these values, the function says, okay, I'm going to take the input, I'm going to return the exact same thing. Takes the input, returns the exact same thing. That's the line y equals x. But it says when you're negative, when x is negative, I'm going to take this input and I'm going to give you the negative of it. And that's the line y equals minus x. Now, what does that mean? What's the use of this? This function essentially gives you the absolute value of any quantity. Let's say length. Whenever you are measuring length, can length be negative? No, it can't. Displacement can be negative because it is a vector quantity. But can distance be negative? No. That means, let's say you travel 100 meters to the north and again 100 meters back to the south. Now the total displacement is 0, but the total distance is 200. So modulus, what it essentially does is it takes the quantity and only gives you the absolute value. The absolute value of displacement is distance. Now, ceiling function. This is quite an interesting function. What it does is it takes the input x and it spits out the least integer that is greater than or equal to x. Let's look at some examples. 5.1. What is the least integer that is greater than or equal to 5.1? When we consider equal to, we get 5.1, which is not an integer, so we have to go greater than that. 5.2, 5.3, 5.4, so on. We go to 6, and that is the least integer greater than or equal to 5.1. 0.11, 1. 5.7, 6. 0.9, we say 1. And the plot of this function looks something like this. For everything between 0 to 1, not including 0, but including 1, the answer is 1. And then for everything gr greater than 1, doesn't matter how small it is, the answer is going to be 2. And that stays the same till 2, including 2, that is. And again, doesn't matter how small the increase is, adds anything small to 2, it's gonna jump, and the answer is 3. Let's look at negative values. Actually, let's see minus 7.6, right? What is the ceiling of minus 7.6? Now, if you take the equality minus 7.6, that is not an integer, so we have to go greater than that. Now, is minus 7.7 greater than minus 7.6? No, that's actually less. So we go to the right. We say minus 7.5 is greater than minus 7.6. And you keep doing that. The first integer that you're gonna encounter is minus 7. So the answer for that is minus 7. Another example, minus 4.4. The ceiling of that is going to be minus 4, because minus 4 is the least integer greater than or equal to minus 4.4. Perfect. Now, there's infinite number of functions in the world. I want you to explore as many as you can in your time, but I want you to look at these two for as today's homework, if you will. The function x times mod x, and what is mod x? You looked at it. Okay, so I forgot to write this thing. Mod x f of x is modulus of x, which is x when x is positive and minus x when x is negative. I need you to look at x times the absolute value of x and also the floor function. You looked at the ceiling, now I want you to look at the floor function. Now, functions are essentially a subset of a bigger mathematical uh, concept called relations. Now, what is a relation? A relation is essentially a mapping. It's a mapping from one set to another set, or it's any set of ordered pairs. So you take 140, that's one set, and 3, 2, minus 2, 0, that's another set. A relation is any type of mapping from this to this. If we look at 4, it's being mapped to 2, and it's also being mapped to minus 2. In this case, if one element is mapped to more than 2 elements, it's called one-to-many relation. And look at this. 1 and 2 are mapped to 4, and 3 is mapped to 5 and 6, meaning one element is mapped to more than one elements. So one to many is happening, and also many elements are being mapped to one. So many to one is also happening. This thing is called many to many. Now we have to know that functions are a subset of relations, meaning every function is a relation, but not every relation is a function. Because in this example, one input has more than two outputs, which cannot be a function. So that is not a function, and neither can this be a function because 3 has more than two outputs. So even this cannot be a function. Again, you have to know that two inputs can have one output, but this cannot happen. A function can only have one output. Now, when we talk about the domain of functions, can it be anything? Can you say any number that is possible in math, any number whatsoever can be in the domain of a function? Well, not quite. There's majorly three restrictions that doesn't allow some things. What are they? One is division by zero. Whenever you have a function like 1 over x, let's say that's a function. It takes an x and it gives you 1 over x. Let's say f of x is 1 over x. You cannot input 0 here and expect an output. You cannot, because division by 0 is not defined. So that's one restriction. You cannot divide by 0. So anything that makes the denominator go to 0 cannot be in the domain. So in this case, 0 cannot be the domain. And next is even root of a negative number. What does that mean? We have square root of 4, which you know the answer is 2. But can you have the square root of minus 4? No. So something in the square root of a something in the square root, that thing cannot be negative. This also applies to not just square roots, but also any even root, essentially. Let's say the fourth root of minus 17, minus 16 actually, let's do that. Minus 16 doesn't exist. We know that the fourth root of 16 is 2, but the fourth root of minus 16 doesn't exist because you cannot multiply four numbers. Let's say I take minus 10. You cannot multiply a negative number four times and get a negative number. It'll be positive. So for any even root, the thing inside cannot be negative. And we cannot also take the logarithm of a negative number. What is a logarithm? We'll discuss that much later in the class, not right now. Let's look at an example. We have a function f of x which takes an x and gives you 1 over the square root of 2 times the input plus 5, or simply 1 over the square root of 2x plus 5. Now, there's two things that kick in here. One is the root, square root. We saw that any even root can take only non-negative numbers, meaning the square root of 5 to the square root of 2x plus 5 is only real if 2x plus 5 is not negative, meaning it is greater than or equal to 0. Subtract both sides by 5, you get 2x is greater than or equal to minus 5. Divide both sides by 2, you get x greater than or equal to minus 5 over 2, which is minus 2.5. So, okay, we got this. X, the first restriction tells you x has to be greater than minus 5.2. Cool. Now let's look at division by 0, because x can be greater than or equal to minus 5 over 2, but if x is equal to minus 5 over 2, if x is equals to minus 5 over 2, this thing is 0, meaning the denominator is 0, meaning you're dividing something by 0, which can't happen, meaning x cannot be minus 5 over 2. Now, taking these two, we say the common constraint out of these two is that x has to be greater than minus 5 over 2. That's the final conclusion. And the domain of this function is minus 5 over 2 to infinity, open brackets. What do I mean by open brackets? It's this. This means the point is not included, and this means the endpoints are included. You can also have combinations of open and closed like this, or even this. Now I laid out the plot of the function just for reference. What happens is, firstly, at x equals to 0, when you throw 0, f of x throws out 1 over the square root of 5, which is somewhere around here, a positive quantity, sure. So that's there. And as you go to, as x gets bigger and bigger, the denominator gets bigger and bigger, meaning the fraction gets smaller and smaller, so it goes to 0. And when you keep going to the left, what happens is x slowly approaches minus 502, which is minus 2.5. And as it does that, the denominator gets closer and closer to 0. And when that happens, the fraction blows up to infinity. It gets bigger and bigger and keeps going to infinity. Again, at that point, it's you can say undefined for now. Although it will go to infinity, we'll deal with the infinities in few chapters. Symmetry. Now, functions can be rather interesting at times, and there are three types when you talk about symmetry: even, odd, and neither even nor odd. Now, what is an even function? Mathematically, even function is defined like this: f of minus x is equal to f of x. F of minus x is equal to f of x. Now, what does that mean? It means that if you take an input, you throw it into the function, it's going to give you some output. F of minus x means that if you take the first input and take the negative of it and throw that into the function, it still gives you the same output for an even function. So you throw in 7, it's going to give you some 200, let's say, as the output. You throw in minus 7, it's still going to give you the same output. Examples of even functions are x squared, which looks like this. X squared of 2 and minus 2 is the same. X squared of 10 and minus 10 is the same. And modulus x is another even function. Modulus of 100 is 100. Modulus of minus 100 is also 100. Cosine of x is also an even function. It starts with the maximum value at 0, and as you go to the right, it decreases, reaching 0 at pi over 2, and then further decreases till minus 1 when you reach pi. Now, when you start from 0 and you go in the negative direction, it still gives you the same pattern, keeps on decreasing, goes to 0 at minus pi over 2, and goes to minus 1 at minus pi. So that's an even function. Constant function is also even function because if the value is the same for every single input, it will be the same for two inputs which are the same in magnitude but opposite in sign. So you take something like, it's the same. In fact, every single input has the same output. The punchline here is that even functions have what is called a reflectional symmetry. I repeat, they have a reflectional symmetry. About what exactly? About the y-axis, about the line x equal to 0, which is nothing but y-axis. So if you consider an imaginary mirror to be in the place of the y-axis, if a function stands in front of it, it sees itself on the other side. That's the reflection, and that is an even function. Odd functions. Mathematically, odd function says that if you throw an input and it gives you some output, now take the negative of the first input and throw it, the function is going to give you the negative of the output of the first function. Meaning f of minus x is minus f of x. So the output of a negative of input, some input, is the negative of the output of that input. Examples of odd functions are x cubed, which looks something like this. 2 cubed is 8, but minus 2 cubed is minus 8. Y equals x, which is called the identity function. When x is 10, y is 10. When x is minus 10, y is minus 10, meaning minus of the first input. The sin x starts from 0, goes to 1 when x is pi over 2, and then again goes back to 0 and makes this shape. But when you go to the negative side, it gives you the same value but opposite inside. So sine starts from 0, and if you go to the negative side, it decreases and reaches minus 1 when x is minus pi over 2, and then goes back up, makes that pattern, which is exactly the negative of this side. For this, what we observe is that odd functions have a different kind of symmetry. They do have symmetry, but not the symmetry as that of even functions. They have what is called rotational symmetry. A rotational symmetry. About what point? About the point 0, comma 0, which is also called the origin. So that's the pivot about which the function is rotated. How much is it rotated? It is rotated 180 degrees. So we start from there, use origin as the pivot, and we rotate 180 degrees to get the negative side. Meaning if you block, if this is blank, you take this side, rotate it by 180, you get this side. Even same here. Let's say this side doesn't exist. Let's say we did not draw the negative side. What we do is we take this and rotate it 180 degrees. We get the other side. The same with x cubed. Take this, rotate it 180 degrees. You get this side. Now, do all functions need to be either even or odd? Not exactly. Some functions are neither. For example, y is x plus 3. When you look at it, it's a line again. When you look at it, okay, is it even? For evenness, you have to look at reflections. Now, if I consider the y-axis to be a mirror, is it being reflected off of this mirror? No, not exactly. So this is not even. So this is not even. This is not even. And I look at the origin. I look at the origin. Now, if I take this side and rotate it, if I take this side and I rotate it 180 degrees, that should be somewhere here. Now, is that what is happening? No. So this is also not an odd function. It's neither even nor odd. Let's look at some examples. F of x is x to the 4 plus 2x squared. Let's calculate what f of minus x is. F of minus x would be. Now, to find that out, we just take minus x and throw it wherever we see x. So simply replace minus x simply replace minus x with x. I'm sorry, replace x with minus x. Replace x's with minus x. Minus x's. Do that and you get minus x to the 4 plus 2 to the minus x to the 2. Now this thing can also be written minus 1 to the 4 times x to the 4 plus 2 times minus x squared can be written as minus 1 to the 2 times x to the 2. This would be x to the 4 plus 2 times x to the 2, which is nothing but the original output, meaning f of x. F of minus x is f of x. This is an even function. Perfect. Let's look at another function. G of x is defined as x to the third minus 2 times x. Now what is g of minus x? I'm sorry, there is a typo. It should be g of minus x. And that's minus x to the third. Minus 2 times minus x. That would be minus 1 to the third times x cubed plus 2 times x, because minus of minus is plus. Now this is minus x to the third plus 2x, which if you take minus 1 as the common factor, can be written as minus 1 times x cubed minus 2x. Again, just if you just want to make sure, FOIL this out, it's going to give you minus x cubed, minus of minus is plus 2x, which is minus g of x. So g of minus x is minus g of x, meaning this is an odd function. Let's look at a third example. H of x is defined as 4x plus 4. What is h of minus x? That would be 4 of minus x plus 4, which is minus 4x plus 4. But wait a minute. Can we write this in the form of h of x or h of minus x? Okay, so if let's see what h of x is. That's 4x plus 4. What is minus h of x? That would be minus of this thing, which is minus 4x minus 4. Okay, so h of minus x is neither this nor that. So it's not exactly even and it's not even odd. So it is neither. That's it for today, guys. I'll continue this with types of functions, and let's also look at domain and ranges of different functions, followed by limits. Let me know if you have any doubts. I might follow this up with a few problems related to functions, but since we do have some uh, functions are not fully yet done, we still have around half of that to be discussed. So yeah, I'll see where I wanna place the practice problems in. But for now, that is it. Again, as a homework, I need you to look at these two functions, which are the floor function and also x times modulus of x. That is it. See ya, guys. Thank you. Bye bye.